Okay, so we'll start over. Let's try this again. So, Mark wants to meet his friend Jeremy after school to ask him some questions about their chemistry homework. On a typical school afternoon, Jeremy either goes to the park for some exercise or goes to the library to complete his homework. Jeremy has previously told Mark that he goes to the park 2 out of every 5 afternoons each school week. If Jeremy goes to the park, the probability that Mark will meet Jeremy in the park is 0.2. If Jeremy goes to the library, the probability that Mark will meet Jeremy in the library is 0.7. These scenarios are represented on the tree diagram below. So first it wants us to complete the tree diagram. All right, of course, each little branching of trees has to add up to 1, right? So if there's a 0.6 chance he goes to the library, then there is a 0.4 chance he goes to the park. All right. And if there is a 0.7 chance that they meet at the library, then there is a 0.3 chance that they do not. All right. So now it says here, if Jeremy goes to the park, the probability that Mark will meet Jeremy in the park is 0.2. So this is 0.2, which means this has to be 0.8. Any questions or concerns over part A? Okay. So B, find the probability that Mark will meet Jeremy that afternoon. So there's 2 different scenarios in which they will meet. All right. So if they meet in the park, the probability that they will meet in the park, all right, is 0.4 times 0.2. All right. And then we add that to the probability that they will meet in the library, which is 0.6 times 0.7. All right, so this, I believe, is 0.08. And this, I believe, is 0.42. So that would be 0.50. Now, I did that with no calculator, so hopefully I did not make a mistake. Okay. All right. Number 2. During an exam that has a total of 8 questions, Paula correctly solved questions 3, 4, 6, 7, and 8. During the same exam, Quentin correctly solved questions 1, 2, 3, 6, and 8. Represent this information on the Venn diagram below. P represents the set of questions correctly solved by Paula. Likewise, Q represents the set of questions correctly solved by Quentin. All right, so their overlap is 3, 6, and 8. So those would go here, 3, 6, and 8. All right, that means Paula gets 4 and 7 over here, and Quentin gets 1 and 2 over here. All right, now that we have 1, 2, 3, 4. We're missing 5. That means neither of them got 5 correct, so it's out here somewhere. All right, and then we had 6, 7, 8. All right, so that encompasses all of them. All right, B, find the number of P union Q. All right, so that is just the total number of elements that are in the union of P and Q. That means the total number of elements that are in P and or Q. All right, so here we have 1, 2, 3, 4, 5, 6, 7 of them. So this is just 7. All right, find the probability that a question at random has been solved correctly by Paula or Quentin, but not both. All right, well, 4 and 7 were solved correctly by Paula, but not Quentin. 1 and 2 were solved correctly by Quentin and not Paula. So that's a total of 4 of them out of the 8 questions. So 4 out of 8. Of course, if you want to reduce that to 1/2 or 0.5, you're more than welcome to. All right, but you don't have to reduce. Okay. Number 3. A 6-sided die has 3 sides that are white, 2 sides that are blue, and 1 side that is red. Lily rolls this die twice and records the colors of the upward side both times. The following tree diagram shows all the possible outcomes of these 2 rolls. A. Find the probability that both dies rolled show red. All right, so that means we have to go red, red. All right, so that is 1/6 times 1/6, which is just 1 over 36. B, find the probability that at least one of the die rolls shown is white. All right, so we can either go red, white, we can go blue, white, we can go white, red, we can go white, blue, or we can go white, white. All right, those are all of the scenarios where at least one white is rolled. All right, so we're going to want to add all of those up. So here we get 1/6 times 1/2. So I will do B down here. All right, 1/6 times 1/2. All right, then we will add that to 1/3 times 1/2. All right, then we will add that to 1/2 times 1/6. Then we will add that to 1/2 times 1/3. And lastly, we will add 1/2 times 1/2. All right, so that gives us 1/12 plus 1/6 plus 1/12 plus 1/6 plus 1/4. All right, now, I mean, you could do this easily enough in your head just by getting common denominators. But you could just plug it straight into your calculator. All right, but your common denominator would be 12. So this would be 3/12, and 2/12 is 5/12, 6/12, 2 more 12ths is 8/12, and this would be 9/12. Of course, that also reduces to 3/4. All right, so, or 0.75. Any of those would be completely acceptable. Fair enough. All right, I will do C over here. All right, find the probability that the second roll shows red, given that the first row showed blue. Okay, so we now know that the first row showed blue. So we know that we're here. We're already here. So what's the probability that after I'm already at blue, that I get a red? Just 1/6. That's it. Right? We already know the first roll, so we don't even have to factor in the probability of that at all. So that's just 1/6. All right. What is this, number 4? All right. Adam has an unbiased octahedral die, which has the numbers 1 through 8 on it. Bella has an unbiased pentahedral die, which has the numbers 1, 3, 5, 7, and 9. Complete the Venn diagram with the numbers written on Adam's die, A, and Bella's die, B. All right. So, of course, they share 1, 3, 5, and 7. So those go here. I don't know how they expect all of these to be in here. 1, 3, 5, and 7. All right, would all go in the overlapping area. All right. And then, of course, 2, 4, 6, and 8 would go here. And just 9 would go here. All right. And of course, we want to be, make sure that we cover every number possible. Of course, up here we have 1 through 8 and then 9. So here we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have them all. All right, so find the number of A complement union B complement. All right, now A complement, all right, is everything that is not, oh, son of a biscuit. All right, I guess I'll do this. All right, A complement is everything that's not an A. All right, so that would be everything here, all right, in red. All right, B complement would be everything here in purple, and that's everything that is not, ah, son of a biscuit. All right, that's everything that's not in B. All right, so A complement union B complement are any of the numbers that are covered in red or purple. All right, so that's basically everything except this overlap here. All right, so there's 1, 2, 3, 4 elements here, and there's one more to make 5 over here. So there are 5 elements, and that's what this N out in front means, just the number of elements. All right, Adam and Bella are each going to roll their die once only. Charlie says the probability that each die will show the same number is 1/10. Right, determine whether Charlie is correct. Give a reason. Okay, so we have 8 possibilities from Adam's die, and we have 5 possibilities from Bella's die. So if we multiply those together, 8 times 5, that gives us 40, all right? And that are the total possible outcomes. Right, there are 40 different combinations that we could have. Right, you could do this with a two-way table as well. It would just be an extensive two-way table, but you could. All right. Now, how many ways can we actually roll the same number? All right. Well, we can roll the same number. We can do 1 and 1. We can do 3 and 3. We can do 5 and 5. And we can do 7 and 7. All right. So that's like all of the possible successes, if you will. All right. So this gives us 4 successes. All right, so of course, probability is the total number of successes over the total possible equally likely outcomes, right? So the probability is equal to 4 over 40, which is 1/10. So yes, Charlie is correct. And generally with probability, there's more than one way that you could kind of reason this out, but that's just the way my mind went. All right. A group of chemistry students at Indiana University Bloomington were surveyed. They were asked which of the following textbook formats, e-textbook, paperback, or hardcover, they used in their courses. The following results were obtained. Okay, so I will try to create a Venn diagram here. Oh, I did way too many then. No. Make that a little bigger. That a little bigger. Move this here. We can make that a little bigger. Put that here. All right, trying to make this as good as I can. Sorry. Okay. So here we will call this E. We will call this P, and we will call this H for hardcover. All right. We know that we have 108 students total. All right. 64 students used hardcover. That means all of the sections inside hardcover have to add to 64. That doesn't mean that there's 64 just down here. That it would then say used hardcover only. All right. So that's how we differentiate there. All right. Same thing with 45 paper book. 64 hardcover, 45 were paper book and hardcover, so on and so forth. With these, it's typically easier to go backwards. All right. So here it says 15 students used none of the three formats. So we know that 15 go out here, outside of all of the circles. All right. 18 students used e-textbook only. So here is 18 in this section of E that is not in any overlapping areas. All right, 35 students used all three. So 35 go in the overlapping area of all three. All right, 49 students used e-textbooks and hardcovers. So e-textbooks and hardcover, this is the area that they overlap. We know that there should be 49 total. There's already 35 in here, so that makes this 14. All right, 68 do e-textbook and paperback. All right, so that's this area of overlap here. So it needs to be 68 total, which means this needs to be 33. 45 students use paperback and hardcover. Paperback and hardcover is this overlapping here, and this needs to be 45 total. So this needs to be 10. All right. We know that 64 students use hardcover. All right. Well, there's already 35, 45, and 59. So there's already 59 in here. That only leaves 5 to get me to 64. All right. And we know that 108 students used paperback. So that means 108 need to be in here total. We already have 10, 45, and 78. So that leaves 30 out here. All right. Now, to double check yourself, all right, well, I guess it doesn't give us how many total people were in the study, so we can't check ourselves. Tough. Hopefully we didn't make any silly mistakes. All right, so here it says use the above information to complete a Venn diagram. Done. All right, B, calculate the number of students who were surveyed. That's what we do to add all of these up. Okay, so we add all these up. We have 15, 20, 30, 60, 95, 128, 146, 160. All right, so hopefully I did that correctly. All right, I'll double check that, right? So 15, 20, 30, 60, 95, 128, 142, 160. I got 160 again. Okay. Okay. C1. On your Venn diagram, shade the set E union P intersect H prime. All right, now if you want to do this like in multiple stages, right? Like first you would do E in one color, like all of E, then you would do all of P in another color, and then you would do everything that's not in H in another color, right? And as long as it's in E or P, but not in H, you're good. Okay. So that color, let's see, I'll pick this here so we can see through it. All right. So if you're in E or P, but not in H, you're good. So here's E, here's P, right? But not the areas of E or P that's in H. So that would be those areas there, right? And then it says find the number that is in this same region, all right? Kind of hard for me to see now. This is 18, this is 30, I think this was 33. So this would be 51 and 30 should be 81. 81. Bada bing. All right, and is that everything? Nope. Okay, we still have this. Oh, okay, so I didn't put that one in here. All right, so we still have parts D and E. All right. D says a chemistry student who was surveyed is chosen at random. Find the probability that the student used an E textbook. All right. So this would be the probability of using an E textbook. All right. So we look here, we say, okay, probability here, we have 18, we have 14, that's 32, and 33 makes 65, and 35 make an even 100. So 100 students used an e-textbook out of the 160 students total. So we would just say 100 over 160. All right. D2 says find the probability that the student used a hardcover given that they had not used an e-textbook. Okay, so this is the probability that we used a hardcover given that we had not used an e-textbook. Right, so that's kind of how that would be in our regular kind of notation there, but you wouldn't have to know that. I just did that so that it was here. All right, so now basically when we do like conditional probability like this, all right, the given condition is what's going to be on the bottom. So here we need to find the number of students that did not use an e-textbook, all right? And then of those students, we take the ones that did use a hardcover, all right? So first, I'm going to look at how many students did not use an e-textbook. So there's 30 here, 10 make 40, 45, and 60, all right? So 60 students did not use an e-textbook, so that's going to be my denominator. All right, now of those 60, how many of them used a hardback? 10 and 5 make 15. So 15 out of 60. Of course, you could reduce that to 1/4 or 0.25, but certainly not needed. All right, D3 wants the probability that a student used at least 2 of the textbook formats. All right, so here, probability of at least 2. All right, so that's basically all of the numbers that are not that are in any overlapping regions. All right, so 10 and 35 are 45, 33 makes 78, and 14 make 92. So that's 92 out of this total 160. Okay. And here, the chemistry department, this is letter E, the chemistry department at IU Bloomington has 2,560 students. Find the expected number of students in the chemistry department that used e-textbooks. Okay, well, in part D1, we found the probability that a student used an e-textbook, and that was 100 over 160. So all we have to do is multiply that by the total number of students in the chemistry department, 2560. All right. And I do not know what that is off the top of my head. All right. So we will just say 100 over 160 times 2560. and we get 1,600. And voila, we are done.